Hello again, and welcome to the second part of this tutorial. In the previous tutorial, we have learned how to model and how to analyze the existing columns, and now we want to add the jacketing part to the existing column. So we assume the size of this column is here, and then we will create another section, and we will remove that one. We'll extrude that area, and finally we use this two new material, which has higher than the existing columns, and also in the steel rebar and the concrete. So we jump to the ABAQUS. So this is the previous result, and we go to again to the part, and we'll start a new model. It's called this time I can call R, which is represent the renovated or retrofitted column, or we can also add a name called jacketing, and it's really deformable solid elements, and we again using 8000. So this approximate, you can change create these grades. So mine is 8000, so it's up to you which grade size you want to use it. So I'm gonna take this one and giving 0 and 0, which is the center point, and then giving 500. Previous was 300, so now it's 500. Again, I want to create one more here. Also I can, but later also I can extrude. Now it's done, and I'm going to consider the same length, 3000 millimeter or 3 meter. Now I can use this command. It's called create cut extrude, and I can select a surface and then select this one, and again I can create a point, a rectangular, and that rectangle is that rectangle can be here, which is this the center of that point, and it's be minus 100 in the X, and also in the Y also minus 100. So I'm gonna give the first point is minus 150 by minus 150. So I'm gonna it automatically take this point, and again we're gonna using 115 positive. Now it's okay, and we can through all, and so the depth is 300, and you can see it. So we created that the renovated or jacketing part as well, and we can automatically come to here, and we can copy this rebar copy, but the copy we can call it R. So we can use same abbreviation, and R, a renovated rebar, and the straps, we can create the new straps as well. So here in the straps I use R steel wraps, and using a wire planer and giving 0 in this point, and the next point is we assume that reducing 2 centimeters in both sides, so totally the size will reduce to 460. So now it's almost done, and we go back to the material, and we want to define 2 new materials. So the second is called E steel, and I'm gonna add again R steel, and using the density. So in case if you conduct some dynamic analysis, the mass is important, and you have to give the mass. So the mass is 7.85 E minus 9. E minus 9. And the elastic is again the same, 200,000 megapascal, and the Poisson ratio is 0.3. The plasticity is, we already mentioned, that's 5 point, which is has 0 point plastic, and then we giving ultimate, and the ultimate is about 1.3% of this one. I can add one more cell or row, and giving 475, and it's almost 23% the plastic strain. So this is simple steel material. And the last one, we already have a CDP30, and I'm gonna import that CDP30 here. It's called, the CDP is already giving here, and I can make some small changes to this material, and then I will give it another name. So this will be 1. I can call 15, and the new one is going to be here, and it's importing to the, and giving rename it to 13. So we shouldn't forget to change the previous section that we defined that material is here, concrete homogeneous, and it's already, because we changed the name, so now we can giving that, and we're creating a new section which is called R concrete, or we can call it jacketing. And it's solid, and the concrete is this concrete, and we have created. And also we should create 2 new section or rebars, and so the first is called R rebar, and this is beam, and we already used beam, and here we already have 10, so we extend this one to be D20, going to be 10 the radius, and D20, and the material is R steel, and we again give the section Poisson ratio as well. Now it's okay, one is done, and the second one is we go to strap reinforcement, so same method, and this time we also create this one, taking this one the same size, but the material is different, so we can add this one. Now we created other materials sections. Now here is called the R straps, and I'm gonna assign this in the straps, so called RS, which we recently defined, and the second is called R rebar, and here, and we're gonna assign this one also, it's called R rebar, and the last one is the concrete jacketing, so R column, and assigning to the column jacketing. We finished the properties, and we go to assembly again, and for the assembly I can first let's come to here, and we can partially remove this one, temporarily we remove this one, remove everything, so remove, so, and now we come back to here, and I want to add that R rebar, and again R straps and R column. Okay, now we are in the same like in the first time. You can see here. Now what we're gonna do is, the first thing that I'm gonna rotate this longitudinal rebar to Y direction, and it should be here, and selecting this command and selecting that element, and then giving its axis is 0, and there should be 1 in Y, and then giving 0 and 90 degrees, so it automatically comes to this area. We can use pause, that the element can be distinguished, and also we can use this as well. So you can see this is exactly in this point. Now what I'm going to do is I'm going to select this one, and I'm going to translate it. So I'm going to translate this one, translate to this direction by 20 milli, and up 20, and inside as much as you wish. So let's see, we're taking from 0, 0, and we're going to up, which is X in this direction, so be 20, and Y should be 20, and Z going to be this one to be like 60 millimeter. Now we can use this transparent method, and you can see here, so it's exactly in the right place. Again, the same method we will apply to the main rebar, and but this time just I wanna change it to 1 centimeters, or just because of the size it should be inside the straps. I can select here, or I can select here again, and here is the so I can just go back here, and it's called R rebar. I'm going to replace this one here and select it this, and taking from 0, 0 and going to up in this direction here, it'll be 10, and 10, and Y should be positive 10, and Z can be like 20 millimeter. Now I can bring that other 3 as well in here, and we also can use this command, and you can see clearly. So here is the rebar, and this is the rebar, and this is the straps. One thing in the last time we did in the first time, what we forget is the rebar orientation. So we give again the orientation because we're using beam, and OK, and the second is the straps, and again we're giving the orientation because it's a C-circle, is a circle cross section, so it doesn't matter, but in other section it will have impact. So done, and we can go to the assembly, and here we want to visualize in case if you didn't define that the orientation, so you are not taking the renders. So you can see here, so this is the rendering. So we actually put this rebar 10. Actually we should we already have 20, it should be 30. So what we're gonna do is, so I'm gonna select that rebar again, and this time I should this rebar, and this time I should do one thing. I should translate this one 20 more, so in the X 20 and 20 in the Y, and in the Z it's can be 0 because we already defined 20. That should be 0 and 20, 20 and 0. So I'm gonna back to here, and this 3, and you can see it's in the right place. So we had some previously some small mistake. Now I can use this command in the linear pattern, and I wanna take that rebar. Just gonna be replace. Select this one, and the size of the size of the strap is 460, so we can automatically give it. We should delete this one, and I'm gonna delete this one and get it 460 and 460, and this one should be 460. Now if I bring it all, and you can see and you can see here you can see here one is here and one is here, but the problem is it takes from the center to center, which is a little different. So we can taking 415 or 440 like this, so that will be correct. So now we should change it this one, or we can go back here and bringing this rebar, and here is this is a rebar, so that's no problem. And the problem is with this one. I'm gonna call replace it, and and this rebar is actually moved almost 10 milli to 1 centimeters up. So I'm now reducing back, just taking 0 0 and taking 0 and bringing in X 0 in Y minus 10 and Z is 0. So we're putting a little. So this side is again we're taking 0 and we're bringing in a minus 10 in the X and minus 10 to the Y and in the Z 0. So if we go back to here, and if you go here, you can in this direction you can see this strap is here, and this remove it, and you can see we actually arrange this one. Still it's not too much correct, but when we considering the embedded region, so it's okay that the impact is not too much. Now the last thing is that the strap should be populated across this column, and I'm gonna select that straps, this one, and I'm going to be replace it. So I'm going to select this pattern and distribute it across the Z direction. So I can select this one and selecting Z and removing this one, and I can give it about 120 centimeters or 150 so it's dependent that we design. So it's almost 20 if I bring everything here, and you can see so this is the last one that could be okay. So now we have completed the assembling of these things, and now what we're gonna do is we're gonna again making some changes. So the first thing is that I wish to do is I want to remove this E column, remove it, and I want to remove this R column and remove it. So now this is the entire rebars, and previously we defined as said here, this called rebars. So this time I want to select all rebars. So all rebar is selected, and I'm gonna deselect these two. Okay, and next I'm gonna back to here everything, and now from top to here I'm gonna remove it, and now I want to rotate this to this is rotation, and I can select the everything here, and then gonna rotate it. So I can select this direction, and automatically across the axis is automatically taking. If I take this one, it should be down. I'm gonna give it a negative, so it will be automatically positive. Okay, so here is some if I add everything, so it's different area. So what we're gonna do is I can use this one, undo, and I can select these all the beam columns. I'm gonna select here and select all select all, and remove this one and remove this one, and I'm gonna considering this one, and taking this point and adding all, and putting that point to this point. So exactly that one is a cross section, will be inside together. Now we are finished, and one more thing is we can create some surface to contact, but later we will do in the interaction. So we're gonna step is the same we previously defined, and interaction we will re-edit the interaction. Actually the interaction is once the embedded region one side is okay, the embedded region which is rebar is already we defined, and the second is we OS region, we want the second part also should be selected. So this is also, and now you can confirm the entire structure is embedded together. So we do not we can also considering changing the coupling. Previously we just applied load here, but the surface increased. We can reselect the surface, and we can put keep the shift as well, and here, and we can do the same things in the bottom as well, and we can go surface and keep the surface shift, and okay. Now we want to create one surface contact between these two concrete, because so in we should create one analytical contact. In case I want to create a contact, and I can automatically see here, and the program will find for me the available contact. So find contact, and you can see here is 4 contact already appeared. So here is the type of contact that you wish to do. Here is the properties. In case if you use some sort of cohesive material or some contact with some properties, you can add, but in reality it's quite stiff, no movement will allowed, because in recently project, so they're using a sort of nail. First they throwing to this concrete and then leaving that side and then weld it together, so it's quite tight. So now I create that tie in there. Okay, we finish the interaction as well. So the loading is previously applied at 20 millimeter in the top. You can check it again. The bottom is fixed, and top is applying 20 millimeter displacement. And in the step also we created that previous output. And mesh, just we go to mesh because we have a new part, and this is the first part, and we want to create a mesh is as a default. And yes, and the second is the R rebar, and going to use this same mesh size, mesh it. And the last one is concrete. Here is the concrete is actually yellow, so we can create a structured mesh. So for this purpose we can go back to the in the part. Let me try here. Yeah, we can create a cutting, so I can create a cut between this point and the verticals. So this is the bottom, and the second one is here again, and I'm going to this one and to this one. So we created this structured mesh, and I'm giving previous was 115, let me giving 50 smaller, and now we are here. So this is quite okay and acceptable. Go assembly, and you can see the mesh is equally meshed. Now we do not have anything else. We just go to here and create a job, and it's called, previous was E, and call it column. So Retrofitted Column Analysis. And you can change something here, but I keep this one and submit the job. I can use monitoring. So now it started running, and it will take some time to finish. So I will stop here after the analysis completed, then we'll be back and we'll discuss on the result. Welcome back, and the analysis actually aborted. Let's see what's the reason. So the reason is it's called too many attempts made for this increment. I should say there is one thing. Let's see, the attempt is like 6 times. We can increase this attempt, and we can go to the analysis step, and it's called other, and it's called solver, control, and manager, and we can select the static, and then we can specify not here, no, not here, and in the general solution control here, and static, it's called continue, and you can increase the attempt So comes to the time increment, and here is called more, and here is attempt is like 5. You can increase this to 15, like 15, and as well as some other parameters, but we don't need. There is one thing that I should say that that's quite easy to get the result. Change or replace the analysis from the static to a dynamic analysis, or use static risk analysis. This is also quite important. And also other solution is reduce the connectivity of the elements, and that's also impact for the convergence and also solution. But with this, because the formation is quite large, so in each attempt we cannot converge more, so the analysis challenging and it need to stop. So we can go to the result, and for 6 increment about almost 4 seconds, the structure is damaged already here, and you can see this is the concrete tension damage, and this is the compressive damage, and this showing concrete has a loss of portion is cracked and it's damaged. We can see the curve deterioration here as well. We also we can comes to the here, and we're gonna take the rebar and we're gonna call it replace with the rebar, and we come back to here and using stress, and you can see the concrete is already reached to the ultimate stress. So we wanna make some display, some rendering, and now you can see, let me make it a little too, make it double and see how it looks like. So this is the rebar, and it's already yield. We go for the comparison, and this is the called existing column, which we already plotted in the previous part, and now we're gonna create another one, ODB output, which we recently analyzed the retrofit parts. When you save it as it is, and here is the giving new part or new renovated structure. Now we go create operated, and using combine, and previously using a -1 times to U2, and again a comma, and -1 times 2 reaction force. So we're gonna save it. This is called R column. Now we can compare this with the existing one. So existing and renovated. I'm gonna plot together, and you can see how much the difference is. So significant difference can be observed here, and it's increased by almost 5 times, 4 times, 700 kilonewtons, and it's almost 120 like this. Quite a large gap. So we can now observe this gap here as well. So the structure, this rebar is quite still stable, but the duration here in the plot is the same. The duration is quite large because you can analyze based on your knowledge, but that this duration is quite sharp, and it reduced significant. So the structure or the column seen significant damages. So therefore the program will not convert that so much large gaps. So that's the problem. In case if you want to continue to see to 20 millimeter deformation, so it's not a difficult job, and you can allow the program to change the analysis type to dynamic, and it will be converted. Or also change the attempt parameters, which we already discussed, and it will reach this one. So, but for me, because my main point was the gap, how much that part, that retrofitted part, can affect or impact the structure. So we can see it's quite large, only in the strength. In case if we have some movement in the structure, so that will be some sort of other effects. But because mostly in the first damage is, you can see here in this area. So when this rebar is yield, so the concrete compression phase significantly reduced, and therefore the deterioration part is quite large. So this is the end of the tutorial, and like this you can do other innovative methods, such as using some sort of steel or fiber elements as well. In fiber element we also did such a tutorial as well. So if you have any question, please put in a comment and we'll find time to answer you. See you next time.